Good morning, everybody. Today we will discuss random variables and probability distribution. We already discussed when a coin is tossed thrice, what is the sample space? When coin is tossed three times, what is the sample space? We can get head, or head, tail, head, tail, head, tail, head, tail. These are the possible outcomes when a coin is tossed. We already discussed it. This is the sample space when a coin is tossed thrice. If we throw a coin for three times, we will get these are the outcomes. In these outputs, if you observe, if I am thinking probability of getting head when a coin is tossed once is treating as a success. So probability of getting one head when a coin is tossed once is probability of success is 1 by 2. So getting head is 1 by 2 when a coin is tossed, and getting tail is 1 by 2. P equal to 1 by 2, Q equal to 1 by 2. P is called as probability of success, Q is called as probability of failure. So how many times I am getting head there? How many times I am getting head there? So how many times I am getting head there? When a coin is tossed. For example, here is there any head? All the tails means no head. So I am getting 0 heads. Or if I am considering head is a success, here 0 heads, no success. Now here in all these three, 1 head. So in all these three, I have only 1 head. And in these three, tail, head. In all these three, I have 2 heads or maximum 3 heads. So when a coin is tossed, the number of heads I am going to get are 0 or 1 or 2 or 3. The number of heads I am going to get are 0, 1, 2, 3. Like this, if I am giving numericals to the number of success, instead of taking probability of getting head equal to 1 by 2 and keep that aside. So number of success means getting head is considered as success. Then I am getting 0 heads, 1 heads means 0 success, 1 success, 2 success, 3 success, like this. If I am giving the numbering like this, then this is called as random variables. So these 0, 1, 2, 3 are called as random variables. X is a random variable with varying number 0, 1, 2, 3. Now probability of this random variable is called as P of xi. Is probability distribution. How can I distribute this probability? The probability of getting 0 heads is 1 by 8. Getting 1 head is 3 by 8. Getting 2 heads 3 by 8. And getting 3 heads is only 1 by 8. So probability of getting 0 heads is 1 by 8. The chance of occurrence of 1 head is 3, so 3 by 8. Chance of occurrence of 2 heads is 3, so 3 by 8. But occurrence of all the 3 heads is only 1, so 1 by 8. So probability distribution of 0 heads is 1 by 8, 1 head is 3 by 8, 2 heads is 3 by 8, 3 heads is 1 by 8 when a coin is tossed. This is called as probability distribution, and this is random variable. So random variable. So, and one more thing, sigma of P of xi means adding all these three, what you get always 1 by 8 plus 3 by 8 plus 3 by 8 plus 1 by 8. So 8 by 8, this is 1. So sigma of P of xi in a random variable, our probability distribution is always 1. Let S be a definition of random variable. Definition, you can say. like this. Definition of a random variable. If S be a sample space associated with a random experiment, S be a definition of a random variable. S be a sample space, S be a sample space of a random experiment, I told you already what is random experiment, whose outcome is unknown, of a random experiment, associated with random variable x, with random variable. Just now only we discussed quantitative values of the success. Random variable x. Then x is a mapping from a function. X is a mapping from S to R. Then a function x from S to R is called as a random variable. PDF, probability distribution function. Suppose x is a random variable connected with a random experiment. Suppose x is a random variable connected with a probability function, P of x, probability function P of x such that probability function P of x such that f of x equal to P of x less than or equal to x. F of x equal to P of x less than or equal to where f is a mapping from R to R for every x belongs to R. F is a mapping from R to R for every x belongs to R. Is called as a probability distribution function. PDF or a probability is called as a probability distribution function. Is called as a probability distribution function. PDF. Probability distribution function, PDF, where implies this is a probability distribution function. P of x less than or equal to x I am saying. So probability always lie between 0 and 1 implies f of x always lie between 0 and 1. F of x always lie between 0 and 1. And for every x1 comma x2 or x1 less than or equal to x2, f of x1 less than or equal to f of x2. And we can say that sigma p of xi is always 1. Sigma p of xi is always 1. If x is a random variable function, if x is a random variable and P of x equal to xi is known. P of xi equal to xi is known with range xi equal to 1, 2, 3 and so on, or xi equal to x1, x2, x3 and so on, xi and so on, with range x1, x2, x3 and so on, with range x1, x2, x3 and so on, then sigma xi into P of xi, sigma xi into P of x equal to xi, or simply we can write P of xi, is known as mean, is known as mean of the probability function, is known as mean of the probability function, mean of the probability distribution function, PDF, probability distribution function, and sigma xi minus mu, sigma xi minus mu whole square into P of xi, and sigma xi minus mu whole square into P of xi is known as variance, is known as variance. Then mu is equal to, this mu is nothing but mean. So mean is represented usually with mu, and variance usually with rho square. Variance is represented with rho square. So rho square equal to sigma xi minus mu square into P of xi, and mean mu is equal to sigma xi into P of xi. This is the definition of mean and the variance. If you simplify the variance formula, rho square equal to, definition is saying sigma xi minus mu whole square into P of xi. If you simplify this, what you will get, will observe sigma of a minus b whole square, a square plus b square minus 2ab 2 mu xi into P of xi. Now if you open the brackets, what you will get? Sigma xi square into P of xi plus, is it visible? Or you write in the top? Is equal to sigma xi square into P of xi square into P of xi plus mu square. I can write outside the mu sigma, because mu does not depend on the sigma, mu is a constant, mean we have already discussed it. Now mu square into sigma P of xi, mu square into P of xi. Mu square is a constant, I am writing outside the sigma, so mu square sigma P of xi minus, again 2 mu is a constant, I am writing outside 2 mu into sigma xi into P of xi, sigma xi into P of xi, sigma xi into P of xi. Now this becomes sigma xi square into P of xi plus, this is mu square into sigma P of xi, means we already discussed it, sigma P of xi is 1. Sigma P of xi is 1. Sum of all the probabilities is always one sample space. Minus 2 mu into sigma xi P of xi is again mu, mean. Now this becomes sigma xi square into P of xi minus, this is plus mu square minus 2 mu square becomes minus mu square. Is sigma xi square into P of xi also can be written as E of x square. E of x square. E of x square minus mu can be written as E of x. Mu can be written as E of x. Mean also can be represented with E of x. Expectation is called as expectation of x is called as mean. So mu is equal to mean. E of x also equal to mean. Mu. So mean can be represented with mu or E of x. Both are one and same. Because we will ask instead of mean, find the expectation. Expectation is also nothing but the mean. Another name of the mean is expectation. That's why I am writing this also. E of x whole square. So simply we can write mean rho square equal to sigma xi square into P of xi minus mu square. So remember the formula. Sigma xi square into P of xi minus mu square gives you rho square is nothing but variance. Rho square means variance. And standard deviation SD equal to root of variance. Root of variance is called as standard deviation. Is nothing but root of this is represented with rho. Obviously root of rho square is rho. So that's why variance is rho square, standard deviation is rho. Is sigma xi square into P of xi minus mu square, where u is called as mean. So mean u equal to or E of x equal to sigma xi into P of xi. This is mean. So remember these three formulae very well. Now we will discuss some problems on this concept, and this is for 7 marks. Mean, variance, standard deviation of the random variables fixed on 7 marks. Probability, from probability I told you will get 2 7 marks. One is from the probability theorems, addition theorem or Bayes theorem, or sums on those two. And the second 7 marks is from this random variables. So 2 7 marks. One is from that, one is from this random variables, this subtopic. Okay. Now we will do examples of one and then we will go for the exercise. Find the mean and variance. Find the mean and variance when a cubical die is thrown, giving the number of phases that shows up. Find the mean and variance. Find the mean and variance when a cubical die is thrown. When a cubical die is thrown, the phase comes up to be considered as random variable. Find the mean and variance. So when a die is thrown, what are the possible outcomes? He is asking to take that as the random variable. So xi is equal to, what is xi when a die is thrown? So possible outcomes are it can be 1, or it can be 2, or it can be 3, or it can be 4, or 5, or 6. So possible outcomes when a die is thrown are 1, 2, 3, 4, 5, 6. So these you can take as random variable is saying. Now what is the probability of getting 1 when a die is thrown? So probability of getting 1 is P of xi, so 1 by 6. And probability of getting 2 is also 1 by 6. Getting 3 also 1 by 6. 4 also 1 by 6. 5 also 1 by 6. 6 also 1 by 6. 1 by 6. This implies mean is asking first of all. What is mean? Mean mean mu is equal to, or E of x equal to sigma of xi into P of xi. Sigma of xi into P of xi. So sigma xi means, sigma means sum. Xi into P of xi means multiply these two, like your 10th class. In your 10th class you will find fi xi to find the mean. Same concept here, probabilities. Sigma fi xi you found. This into this you will make another column, then you will add up. Same concept. So fi into xi you use it to do. Here also same, P of xi into xi. So 1 into 1 by 6, 1 by 6, plus 2 into 1 by 6, 2 by 6, 3 into 1 by 6, 3 by 6, 4 into 1 by 6, 4 by 6, 5 into 1 by 6, 5 by 6, 6 into 1 by 6, 6 by 6. You can make another column for xi into p of xi and do. Otherwise you can directly do. There is no restriction here. So you can take 6 is the LCM. So becomes 2 plus 1, 3, 3 plus 3, 6, 10, 15, 21. So 21 by 6. So total mean equal to 21 by 6. 10, 15, 21 by 6. 3 2 ja, 3 7 ja. So mean is equal to 7 by 2. Mean of the probability distribution equal to 7 by 2. Next is also asking variance, mean and variance. How to find the variance? Just now only we discussed variance formula. Variance equal to, we proved just now only variance rho square equal to, variance rho square equal to sigma xi square into p of xi. Sigma xi square into p of xi. P of xi. Means here also you can make one more column, or you can directly do, or do it directly. Nothing will happen, you will get full marks, don't worry. So xi square means 1 square. 1 square, 1 into 1 by 6, 1 by 6. Plus 2 square, 4 into 1 by 6, 4 by 6. 3 square, 9 into 1 by 6, 9 by 6. Squaring and then multiplying. Sigma of xi square, p of xi. Minus mu square, minus mu square. This is the variance we learned. So I am doing sigma xi square into p of xi square. P of xi first. So 3 square, 9 into 1 by 6, 9 by 6. 4 square, 16 into 1 by 6, 16 by 6. 25 by 6, 36 by 6. Minus mu square. Mu is we got 7 by 2. So 7 by 2 whole square. 7 by 2 whole square. This is equal to LCM of all is again 6. So 9 plus 1 10. 10 plus 4 14. 14 plus 16 30. 30 plus 25 55. 55. 55 plus 30 85. 85 plus 6 91. 91 by 6 minus 7 square 49 by 2 square 4. If anything is cancelled, you can cancel. So LCM is calculation taken 10, 14, 30, 55, 85 plus 6 91 by 6 minus 49 by 4. So LCM of 6 and 4 is 12. 6 goes 2 times. 2 1 are 2, 2 9 are 18. Minus, this is 4 goes 3 times, 3 9 are 18, 3 9 are 27, 3 4 are 12 plus 2, 14, 3 9 are 27, 3 4 are 12 plus 2, 14. So left out is 182 minus 147, 1 minus 7, 5, and this is 7 minus 4, 7 minus 4 is 3. That's it, 35 by 12. So 12 3s are, no, 12 2s are 2 point something. 12 2s are 24. Then left out is 11. So I am giving point of 0 110. 12 9s are 108. 20 12 1s are 2.91. Is the variance. So mean and variance is asking. This is mean and variance, how to find. Now exercise 10A. Exercise 10A. And I will tell you only 5 sums from this exercise. There are only 5 sums. 5 or 6 sums. In those 5 or 6 sums, you will definitely get 1 7 mark. You will definitely get 1 7 marker. So learn properly, note down this and then check in your board paper. 1 7 marker 100% you will get. From the only 5 6 sums. What I am going to teach. First, x and p of xi is himself giving the table. And for all the 5 sums, practically you only give the table. You no need to prepare the table. Okay, in example I prepared the table is giving in bars, but in exam sums you only will give the table. Xi -2, -1, 0, 1, 2, 3 also. Now, probability of getting -2, 0.1, K 0.2, 2K 0.3, K 0.3, K. This is the probability distribution of a random variable X. This is the probability distribution of a random variable X. Find the value of K and variance. Find the value of K. Find the value of K and variance. And variance. And variance. And variance. Find the value of K and the variance of X. And the variance of X. So, how to find K first of all? We know that sigma P of Xi is always 1. Sigma P of Xi always 1. Means sigma of all these must be 1. So 0.1 plus K plus 0.2 plus 2K plus 0.3 plus K is always 1. Means adding this 0.1 plus 0.2, 0.3 plus 0.3, 0.6 plus K, 2K, 3K, 4K. 4K equal to 1 and 0.6 to that side. 4K equal to 1 minus 0.6 becomes 0.4. Implies K equal to 0.4 by 4 becomes K equal to 0.1. K equal to 4K equal to 0.4 implies K equal to 0.1. Implies K equal to 0.1. K equal to 0.1. Now I got K. After K he is asking variance. Variance means you must find mean and then you should go for variance. So now next mean. How to find the mean? Means mu is equal to sigma xi into P of xi. Now here K value I know. So substitute this. K equal to 0.1. Now the new table is 2 into 0.1 becomes 0.2 and this is 0.1. So mean equal to, first mean mu is equal to, now mean mu is equal to sigma xi into P of xi. Means this -2 into 0.2 minus 0.2 minus 1 into 0.1 minus 0.1 plus 0 plus 1 into 0.2 0.2 2 into 0.3, 0.6, 3 into 0.1, 0.3. So, simplify. 0.2, 0.1, 0.3 you can cancel. Left out is 0.8. So, mean is equal to 0.8 mean. Next, variance. Variance. Rho square equal to, we know that sigma xi square into P of xi, sigma xi square into P of xi minus mu square, sigma xi square into P of xi minus mu square, is equal to sigma xi square means minus 2 square 4 into 0.1 0.4. Next minus 1 square 1 into 0.1 0.1 plus 0 into 0.2, 0, plus 1 into 0.2, 0.2, plus 2 square, 4 into 0.3, 1.2, 4 into 0.3, 1.2, next 3 square, 9 into 0.1, 0.9, 9 into 0.1, 0.9, minus mu square, mu is 0.8, so 0.8 whole square, 0.8 whole square, so this is equal to 0.4 plus 0.1, 0.5, 0.7, 0.7 plus 1.2, 1.9 1.9 plus 0.9, 2.8. 2.8 minus 0.8 whole square, 0.64. 0.8 whole square, 0.64. So this is equal to 10 minus 4, 6. 7 minus 6, 1. 2.16 is the variance. 2.16 is the variance. 2.16 is the variance. 2.16 is the variance. 2.16 is the variance.